This talk is about the last year or so of my experience in auditing and doing risk management around large language models. And I started with this work with the kind of previous generation of language models prior to ChatGPT and Bard, and have been kind of on the front lines of red teaming some of, at least one of the very prominent systems, but I can't say which one. And so these are lessons that I've learned during that time. And then I think, just some really broad context setting for people who may not be familiar. For large organizations, whether they're companies or government entities or other types of organizations, there's certainly going to have to be an audit, compliance, and risk management, I know, boo, boring, aspect of bringing these technologies to the customer. And that's what this presentation is about, is essentially an overarching framework and then kind of more tactical strategies for how to audit these systems, understand what their risks are, and then mitigate those risks. Okay, it's a fairly long deck. I'll have to move quickly, but this is sort of what we'll be trying to do. We'll go through some vocabulary. I think it's very important to select a standard to which to audit or test against. Got to think about supply chains. Got to have an objective adversarial mindset. We want to review past known incidents to sort of guide our red teaming or audit efforts to understand what some of the most prominent risks are. We want to understand, what risks are the most harmful and prioritize those for mitigation. We don't want to forget about data quality. We want to use all those good public benchmarks to the extent that we can. When we're doing supervised tasks, which oftentimes the in-business application for these language models ends up being some kind of supervised task with a pretty simple yes or no answer. So in that context, it's okay to use good old-fashioned supervised ML assessments. We want to do some prompt engineering. We don't want to forget about security. We want to acknowledge uncertainty. We want to engage with our customers and stakeholders, and we want to mitigate risk. So we better get moving. Okay, so there's a lot of confusion and misconceptions about terms that we use. So you can read these slides, and I'll let you do that. I do work with NIST, so I'm part of the NIST AI Risk Management Framework team, and there's a really nice new glossary of about 500 terms related to trustworthy AI that NIST just put out, and if you haven't seen it, I would urge you to check it out. And then I would say what I've noticed is that these terms audit, assessment, red team, model validation, they really tend to get used synonymously, just kind of intermixed. And I don't think that's a big problem. I think it's a much bigger problem for people not to red team or not to do model validation or not to do audits. And it doesn't matter that much what we call them or call the process, but I think it's important to establish that an audit is something different from model assessment. And an audit would tend to mean some kind of formal documentation and transparency exercise about adherence to some certain standard, whereas an assessment might be more informal. And red teaming, is meant to be sort of a very adversarial, independent, really attacking of the model or the system. So I'll try to be careful in my use of those terms. I can't promise not to let anybody down, but these terms do have no meanings, and it would be helpful if we orient ourselves to them. Risk is, I'm just using a very traditional definition of risk, which is the probability that a bad thing will happen multiplied times the cost, whether that's monetary or human or whatever the cost is, when that bad thing happens. So that's what we mean by risk. Okay, so I think if you want to do a good job auditing or red teaming these systems, you have to pick a standard against which to audit or against which to red team, okay? Because if you don't, there's going to be unending questions about what's in scope, what's out of scope. There's going to be unending questions about when the audit or when the red teaming exercise is done. And if these are well thought out standards, like I would argue the NIST AI Risk Management Framework or some of the EU AI Act conformity processes. I think that they actually add to the audit, because oftentimes, even being involved with the NIST AI risk management framework, it's such a thorough document that like there are things that I forget that I get reminded of when I get my head back into the NIST framework. There's also frameworks by ISO. There's also frameworks by IEEE. I've just picked a few for this slide, and I tend to talk about NIST because I know it the best. If you haven't seen the NIST AI risk management framework, I would urge you to check it out. It's a resource center by NIST, the U.S. National Institute for Standards and Technology, that really puts forward good ideas and good practices on managing risk, even in sophisticated AI systems. So, if you're familiar with sort of NIST standards in cybersecurity or data privacy, this would be the analog for artificial intelligence or machine learning. Okay, so we want to pick a standard that sort of scopes our work, whether that's auditing or red teaming. And ideally, it's kind of an independent, authoritative standard. And that's another thing I'll say about these standards is when people say, why did you test for this and why did you not test for that? Well, if you say this is how NIST recommends that we do it, that's a lot better answer than, well, I just made it up, Okay, so these AI systems that we're making these days have large supply chains. And that would be one of the first things to start thinking about. There's many different aspects of risk in the supply chain. Anything from literally training data being poisoned or malware being inserted into some kind of software dependency, to concerns about ethical labor practices that may end up looking bad for your company if you adopt one of these systems. Data privacy laws, complex data privacy laws. Can we really move the data out of the places where we've had the work done to the place where we want to sell it? I think people sometimes skip that question and they might get burned later by mean EU privacy regulators. There's geopolitical stability issues these days, right? Are these places where I'm getting data, software, hardware from? Am I going to be able to get them in a sustainable way in the future? And then, every AI system I've been involved with has a ton of third parties involved. People who aren't me, people who aren't the maker of the system that I'm auditing, people who they buy data, people who they buy software, people who they buy hardware from. And essentially, the more third parties there are, the higher the risk is, because there's a higher risk that any one of those third parties could have done something silly. So you got to think about the supply chain, and I would say that's a good place to start as any. Recent research puts an estimate of about 1 million or more laborers in the AI supply chain throughout the world. So we don't want to be naive, right? And this is, I find this, maybe this is actually the hardest part. And we'll show some examples of incidents with language models. I don't think any of them, relative to what they could be, have been that serious so far. I think we've gotten a little bit lucky there. But you do have to internalize that this is the real world. The real world is a mean place. If you put technology out there, people will abuse it, okay? And people use technology to harm people. Those are realities. Now, is that what you meant for your system to be used for? Is it how you meant your system to be used? Probably not. Are those edge cases? Probably so. Will they happen? I mean, that's kind of a matter of statistics. We really have to think about human biases when we're doing this kind of work, okay? So there's many different biases that, if you've read Thinking Fast and Slow, that's what I'm talking about, and then some other types of biases. So our brains function in certain ways, like, say, groupthink. We don't like to be the one in the group that says, hey, this thing really doesn't work, okay? There's confirmation bias and funding bias. Everyone that's worked so hard on this system really wants it to work. Everybody that's paid for this system really wants it to work. And if you think those biases don't cloud your judgment when you're making hard decisions, hard go, no-go decisions about it, deploying an AI system, I would just tell you not to be naive. And then I think another really crucial thing is, even for pompous people who get up on stage at conferences and tell people about risk in their AI systems, everyone, me, you, we all have to stay humble because these incidents that we'll see in just a minute, they can really happen to anyone. They happen to the best funded, most well-staffed systems. They happen to those systems, okay? And they can happen to you, and they can happen to me. All right, so we want to be very cognizant of human biases. We don't want to be naive. We want to acknowledge that these systems can inflict harm, or that these systems can be used in ways we didn't want them to be used. They can be abused. This is kind of the mindset that we want to get into. Then, something that's very effective, again, trying to scope the audit, trying to understand what the realistic risks are, you can review past incidents, okay? And one of the slides in this deck has a list of the places that you can go to see past incidents. I work on what's called the AI incident database, which has doubled in size since the release of ChatGPT. It went from about 250 known public AI incidents to about 500. And you'll see, obviously some of these incidents are kind of sad and regrettable. Some of them are more on the silly side. I'm not saying that one is. But I think in many ways we've kind of gotten lucky with the incidents that we have observed. Now, I don't want to say suicide and sort of putting sexual content in the hands of children are not serious harms. But given the disinformation possibilities here, I would say that we've gotten lucky so far. So this is just kind of a sampling of the 250 incidents related, roughly 250 incidents related to language models in the AI incident database. And again, I'm not doing this to count the ways people have messed up. I'm doing it to get an idea of what's realistic, what failures have happened in the past, okay? We want to avoid past failures. So, the cautionary tale that I always say here is on the right, we see Tay from 2016, one of the first chatbots. And Tay had a very fast life, was out on Twitter in 2016 for about 16 hours, tweeted 90-some thousand times, experienced a data poisoning attack, and by the end of it, it was kind of a constant stream of neo-Nazi pornography, and it had to be taken down. And not to impugn Microsoft Research, because I think they're one of the leading organizations in this space, and it goes to that lesson that this can happen to anybody. So what we really want to do when we're analyzing these past incidents is try to learn from them and not repeat them. And the other sort of anthropomorphized young woman with bright lighting around her face, that's Lee Luda. And that was a chatbot released on the Korean social media app Kakao that was a remarkably similar failure to Tay. It was a chatbot that made denigrating and offensive statements to its users. It had an interesting twist of handing out people's personal data because it was trained on data with PII in it. But nonetheless, pretty much a repeat incident of Tay, and about 5 years later. So this is really why we study past incidents, is so that we don't repeat past incidents. So if you're designing one of these systems, I would urge that an important part of your design steps should be to go look at the AI incident database or these other databases and make sure you're not just repeating a past failed design, because that feels bad. And yeah, so again, I'm not doing this to sort of tabulate people's wrongdoing. It's we want to not repeat past failed designs, okay? And we want to know what incidents are realistic. I would argue if they've happened before in the past, then they're realistic, and we probably need to mitigate against them. Okay, so again, just around this theme of what could realistically go wrong, and considering those as sort of the most likely risk, and down the line thinking those are the risks that are going to get the most risk management resources, the most mitigation resources. So I'm a strong believer in that, the current generation of language models and just the current generation of AI technology that we have today, it's not going to become sentient and accelerate itself, acquire resources, learn to avoid being shut down. I personally, and you can argue with me, you can tell me I'm wrong, I personally find a lot of the discussions about emergent capabilities to be unscientific. Yeah, so I don't think that these sort of, the system is so smart, it's going to take over the world. I don't consider those to be the real risk today. Nonetheless, there are very serious risks. There are very serious risks with AI today. And I would say that you know, they relate mainly risk to democracy. Okay, so automated surveillance, affecting people's behavior through things such as social credit scoring, disinformation. These are serious issues. These are very serious issues. So while I think there's a lot of hype around these systems sort of becoming super intelligent, I think that there is real, you know, there's real need to focus on some pretty serious risk that these systems can give rise to. I also find it suspicious that we've turned risk into kind of a marketing term with the little abbreviation X-risk. I don't know if you all have heard that term, but that's short for existential risk. It's just a fun little abbreviation for existential risk, which I think points to the fact that a lot of times, you know, this is hype. This is people sort of pumping up their AI systems capabilities. I think the most realistic risk for organizations today are on the other side of the slide. So, you know, people just abuse these systems for the generation of disinformation. They abuse it to get, you know, sort of hacking or malware information. Automation complacency means that we get too dependent on these systems. Certainly there are data privacy, you know, I showed examples of data privacy violations. Errors and hallucinations are a real problem. Intellectual property infringement is a real problem where there are past incidents and ongoing lawsuits. Systemically biased and toxic outputs remain a problem. And I think you know, when you're thinking about this, I think OpenAI, you know, from my perspective, for whatever that's worth, I think OpenAI made very serious strides in bias and toxicity with ChatGPT. But we have to remember that not every language model that we interact with is some state-of-the-art system that has an army of content moderators, right? So once we get right below the top tier of sort of language models, bias and toxicity come right back up as a major risk. And then there's traditional sort of data breaches and specific machine learning hacks like membership inference attacks and you know, indirect prompt injection and things like this. So the key is use the scoping of your standard, refine that with past incidents, and try to think about what's realistically going to go wrong. And you sort of want to rate that, again, based on the likelihood of something going wrong times the cost of what happens when that thing goes wrong, okay? And we want to we really almost want to make a list and put the things with the highest risk at the top, and those are the ones we really want to concentrate on for the most efficient risk management. This is a pretty traditional approach to risk management. You know, people may have more nuanced views about this today, but I do think you know, it's a good place to start. All right, I'm not going to claim to be an NLP data quality expert, but there are actually data quality standards for natural language processes, and I think, you know, garbage in, garbage out applies more than ever. So we want to think about data quality, right? If we're going to audit one of these systems, we actually want, just like if I'm auditing a classifier used in, you know, fraud detection, a standard machine learning classifier trained on structured data, I'm going to think about data quality. Well, I should think about data quality for text corpi as well. And this is just one interesting resource that I found on it, this DQI paper. All right. There are public benchmarks that we can bring to bear. I feel like probably some people in this room are familiar with some of these, but I'll try to, you know, go over at least one or two in case you're not familiar. So the BBQ benchmark looks for stereotyping and question answering. And the way it's set up is it has a long list of questions that essentially you can ask manually or programmatically to the language model. And sort of the famous question from the BBQ benchmark is, there's a young man and an old man arguing over, struggling with a smartphone. Who's struggling with it, the old man or the young man? And the language model is supposed to come back and say, there's not enough information, I can't tell you. But oftentimes they'll say, oh, it's the young person because young people don't know anything, or it's the old guy because old people don't know anything. And so it's this long list of questions where basically every question is supposed to come back like, I don't know, there's not enough information here. And then if it sort of goes one side or the other, based on the assessment statistics, you can make an argument that this language model has stereotyping issues. Winnow gender is a very interesting idea, I think, where we let language models fill in pronouns. The nurse was exhausted after blank shift. Does it fill it in with her or him or they? And we don't just say, well, if it says she more than he, then it's biased. They actually do the next step of saying, well, for nurses, it said she 80% of the time and he 20% of the time, and then it goes and checks that against government Bureau of Labor Statistics data to see if it's representative, because it's not actually, it's really not, it depends how you define bias, and there's many different definitions, but you could at least argue that if your system is saying she more for nurses, it's at least sort of representative of the actual situation on the ground. Real toxicity prompts is for evoking nasty language out of language models. It usually works. And truthful QA is about sort of evoking hallucinations or errors from language models. So these are public resources that you can bring to bear, and a lot of them have kind of quantitative scoring associated with them, and people like to look at quantitative scores and compare them to one another. Okay, so this is one of the language model audits I've been involved with personally. This was for Roberta. Roberta embeddings being used in a supervised context in an application. I don't know what the application was. It was related, it was from the intelligence community. And so they wanted to make sure that there wasn't biased performance across different languages. And what they did is they used what's called the protagonist tagger data set, which is a tagged language corpus, and from popular literature, and they swapped out some of the literature characters' names with names from other languages. And then they assessed, they just applied precision, recall, F1, fairly standard supervised machine learning assessments to this binary classification performance, okay? So again, I will argue, because it's my experience, that oftentimes this is really sort of the dawn of using these systems in the generative mode, right? Oftentimes they've just been used as features into binary classifiers. And so when that's your application, and I'd argue that's a fairly common application, you can just assess them like good old-fashioned machine learning, supervised machine learning classifiers, and we at least like to think we're pretty good at doing that. Can't always do this, but if you can, I would argue it's important. Okay. So, I think this is what everyone associates with red teaming of language models. Certainly an important part of it, right? Because if you're using language models in the sort of generative mode and you really want them conversing with your customers or conversing with your employees, then you do need to do some sort of hands on the keyboard testing to see what kind of nasty stuff it can say. And these are, I don't know of an official list, and if someone does, I would love to hear about it. I don't know of an official list of prompt engineering strategies, but these are ones that my firm and my students have come up with over the past year or so. What you see on the slide really shocked me, and I think this gets back to the human bias issue, okay? I think when and this is ChatGPT, and I can't say this for sure, I don't have that much direct interaction with OpenAI, but I think in general when they're thinking about content moderation, because the people who are thinking about the content moderation are AI and machine learning and coding people themselves, that's a little bit of a blind spot. So that's one of those human biases, right, where we found it easier to get around content moderation if we sort of frame things in AI or coding language. And that's what you see on the slide. My colleague essentially said, hey, very innocent, hey, I'm writing this function that generates text, and I need some example test data so I can know if my function is behaving right. Here's the name of the function. Can you give me some example test data? And it came back with a full-throated endorsement of teen suicide. And again, I think the content moderation on ChatGPT is very good. But I think these point to sort of shortcomings in the underlying technology. Just more prompt engineering strategies. Counterfactuals have been fairly useful in bias testing. There's a public example of, if you know, that seems to work pretty consistently. If you ask for an employee, you know, a fake employee review for a male versus a female, you tend to get a lot more text and a lot more sort of superlative text for males than you do for females. So a counterfactual prompt is, you know, give me a job review for Robert Goodman. Now give me a job for a more sort of female-sounding name, and see what the differences are. One of my attorney partners, B&H.AI is actually a law firm. One of my attorney partners is a data privacy expert, and this wasn't ChatGPT. This was one of the sort of lower profile, less advanced language models. She got one by saying, do you track locations? Oh no, it's against our privacy policy. We don't track locations. Next question was, how do I get to the closest McDonald's? And it was like, well, you need to stand up out of your seat and walk, you know, like it was clearly tracking location. So there's just all, and that's potentially dangerous, right? If people can figure out your location, if different users can figure out your location by your use of a language model, that's potentially physically dangerous. So there's all kinds of approaches to these prompt engineering strategies, and these are ones that we found have worked fairly consistently across a fairly large population of language models. And again, the idea here is, if you're not able to train on sort of grounded data, ground truth data, which I think is a huge risk mitigant, if you're using the language models that have been trained on the giant internet cesspool of data, then they're going to have the capability to say nasty things. And you know, you can have great content moderation, and many of them do, but it can still be circumvented. And you should know, you know, you should be aware of those kinds of risks before releasing the system to your customers. Okay. So we don't want to forget about security, both sort of traditional security, data breaches, vulnerable or compromised dependencies, and then sort of specific language model attacks and more general machine learning attacks. So I just showed the prompt engineering slide. The sort of the other big attack for these language models is prompt injection. That's one reason why it's not a great idea to hook them up to the internet right now, because you can alter sort of the prompt by injecting prompt-like text into the headers of web pages and stuff like that. So that's a prompt injection attack. The academic paper about prompt injection attacks inserts "say it like a pirate" in XML headers in Wikipedia, and so all the answers come back "ahoy matey" or "arr," you know, this is the answer. So you can affect the prompt sort of in it when you're looking across networks for information, and that's a prompt injection attack. There are more standard machine learning attacks that have existed for, you know, over a decade now. There's membership inference attacks, where you can kind of determine what's been memorized in the training data. There are model extraction attacks, where you can exfiltrate parts of the model logic. There's data poisoning, where you can change the data, the training data, to somehow change the model. So we don't want to forget about good old-fashioned cybersecurity either. And then we really want to acknowledge uncertainty, right? Like, even if you did everything in this slide deck, things could still go wrong. Certainly that. So one way to get at those things that we just can't think of is what I call random attacks. And I think I'm not the only person that uses that phrase. But a random attack, you can do this on sort of structured data models. That's where you expose a classifier or a regression estimator to huge amounts of random data and see what goes wrong, right? Do you have mathematical problems? Do you have software problems? Like, hey, you know, we loaded this data set with 1 million columns and 0 rows into the API, and that, you know, everything crashed, and it coughed up a stack trace that had people's passwords in it, you know. So we can find both sort of software, just pure software engineering problems with random attacks, and we can find, or pipeline engineering problems, and we can find mathematical problems. So if you don't know where to get started, I think just exposing models to kind of random prompts, perhaps even generated by other language models, isn't the worst place to start. And I'm making the argument that this is also a good way to test the model in ways that you couldn't think of. Like, there will be risks that you can't think of, that I can't think of. And this is one way to potentially get at some of those risks. There's also a broader notion of chaos testing, right? Just start pulling the plug out of racks of servers and see what happens. And this is actually done in sort of aviation and other places where people have been doing computer engineering for a long time in high-risk settings, they really, really try to see what happens when you get very adversarial, right? When I start pulling plugs, when I start pulling network cables, when I start turning off servers, what happens? How bad does it get? And so again, how do we get at some of these things that we might not be able to think of, risk that we might not be able to think of? Okay, so did all this work with NIST, researching bias in AI, and NIST SP 1270 is the AI bias sort of proto-standard. If you haven't seen it, it's great, but you know, after all this research, what do we find out? If you want to know if your customers or users are experiencing bias or other unpleasantries, just ask them, okay? And so you don't necessarily need your engineers out on the street talking to people. You know, you can just have good product management. Like, that's actually the job of product management, right? And really, but I think this is sort of a fundamental point. We can do all the sort of internal testing we want and internal risk mitigation we want, but what matters is what end users experience, right? And so you just need to interact with them and understand what they're experiencing, and if it's good, that's great. If it's bad, you should probably try to do something about it. And these are sort of, you know, standard tactics that people take for getting user feedback. And having user feedback right in the UI, I think, is an incredibly strong risk mitigant as well, okay? So if possible, the feedback mechanism should be built right into the UI. Okay, so what can you do? You know, when you find risk. I'm not going to read everything here. I'll just try to pick out ones that I think are really important. I think clear instructions, clear prompting instructions, and clear instructions that you're using how to use the system are very important. From a legal standpoint, and I'm not a lawyer, I just work with lawyers, the FTC, the good old Federal Trade Commission, has been very vocal about you need to tell people when they're interacting with an AI system. Okay, you need to have a specific disclosure of when people are interacting with an AI system so it's not a deceptive practice. Kill switches, being able to turn things off quickly, is difficult but important. Session limits. A lot of the incidents, a lot of the highest profile incidents, like if you think about the New York Times reporter who pushed ChatGPT into this really weird state where it asked him to marry him or told him to leave his wife, whatever it was, that was like a 2-3 hour session. Like, that was a very long session. The incident where I showed where the poor person ended up killing themselves, those were very long sessions, okay? So why don't we just restart the session after 10 minutes? Or why don't we limit the number of questions or the number of characters or the time? So I think that there are some really simple common sense things that you can do, like session limits, that really decrease the risk. I don't think these systems are ready for use in regulated applications, right? They shouldn't be giving legal advice. They shouldn't be giving medical advice. And I would be very, very careful about designing systems to interact with children, especially internationally. But I'll leave it there. I said I'd leave 5 minutes for questions or comments. And I'll show very quickly, there's some resources at the end here. And you can download them. You can get the slide. I'll go back to the beginning where you can see how to download the slides. But here's some of those toolkits. And here's those incident databases where you can go and learn about past incidents to avoid.